Hello student, good morning. I am Dr.A.J. Sinha, Professor of Chemistry. Today I will continue from the last class. Last class I have discussed oxides of nitrogen, different oxides of nitrogen, and also I discussed structures of nitrogen. Now I am going to discuss nitric acid. Nitric acid is very important. Nitrogen forms oxo acids. What are the examples of oxo acids? Then first example is H2N2O2, also called hyponitrous acid. Second example is HNO2, also called nitrous acid, and HNO3, that is called nitric acid. Again I am repeating. First examples of oxo acid is H2N2O2, also called hyponitrous acid. Second is HNO2, nitrous acid, and third is HNO3, that is nitric acid. Amongst them, HNO3 is most important. How it is prepared nitric acid, that I will tell you. Preparation. In the laboratory, nitric acid is prepared by heating potassium nitrate or sodium nitrate and concentrated H2SO4 in a glass retort. Two things you have to mix and you have to heat. First, potassium nitrate or sodium nitrate, any one, plus concentrated H2SO4, that you have to take in glass retort. Then how will you write this reaction? Then reaction is very easy. NaNO3 plus H2SO4, it will give two products. First, sodium bisulfate means NaHSO4, NaHSO4 plus HNO3. And if you want to prepare it in a large scale, it is prepared mainly by Ostwald's process. Ostwald's, OSTWALDS, Ostwald's process. This method is based upon catalytic oxidation of NH3 by amphoric. This method I am telling you, large scale Ostwald process. Here you will get nitric acid by use of ammonia. Ammonia gas actually it is reacted with atmospheric oxygen. Okay, and it is a catalytic reaction. Catalyst is used. Then ammonia plus oxygen. This oxygen is from atmosphere, that is called atmospheric oxygen. Then ammonia plus oxygen, it gives two products. First, NO2, not NO2, NO, nitric oxide, and second product H2O, water. And this NO now can be converted into NO2. Three steps are there. Then in first step you are getting NO. Now from this NO you will get NO2. with further reaction with oxygen, means NO plus oxygen, you will get NO2. And third step, NO2 and H2O both will react. NO2 and H2O both will react, and then you will get two products. Nitric acid, which you want actually, this will give two products. First product is HNO3. Your purpose is now fulfilled. But here you are getting again one more product, NO, nitric oxide. Then you have seen that you have started reaction with ammonia and oxygen, you got NO. Now in the last step, again you are getting NO. Hence whole process can be repeated to get more nitric acid. Okay. Then now balanced equation I am telling you. 4NH3 plus 5O2. Then we will get 4NO plus 6H2O. And what are the catalyst? Then catalyst is a platinum or rhodium, RH, platinum gauge or rhodium gauge. And temperature, how much temperature? Then 500 K. This temperature is 500 Kelvin and pressure is 9 bar. Okay. This is the condition. Catalyst you can use platinum or rhodium gauge, and temperature is 500 Kelvin and pressure is 9 bar. This is the condition. Then you will get nitric oxide, NO, nitric oxide you will get. Means 4NH3 plus 5O2, you will get 4NO2 plus 6H2O. Now nitric oxide, you got NO. Nitric oxide thus formed combines with oxygen giving NO2. Means 2NO plus O2, you will get 2NO2. 2NO2 means gas, NO2 is gas. Then now in third step, this NO2 gas means 3NO2 plus H2O, water. 3NO2 plus H2O will give 2HNO3 plus NO. Then in this way you got the nitric acid plus extra product NO, nitric oxide, which again can be repeated to get the more nitric acid. NO thus formed is recycled and the aqueous HNO3 can be concentrated by distillation up to 68%. Here after distillation you will get 68% by mass. Further concentration, by further concentration you will get 98%. Okay, further concentration to 98% can be achieved by dehydration with concentrated H2SO4. Because in HNO3 some water may be there, then if you will use H2SO4, then H2SO4 will absorb water molecules. Hence now you will get more nitric acid, means up to 98% nitric acid can be obtained, can be achieved by dehydrogenation with by dehydration, not dehydrogenation, by dehydration with concentrated H2SO4. This I have told about this preparation. Now I am telling you properties of nitric acid, and also I will tell the structure of nitric acid. This nitric acid is a colorless liquid. It is a colorless liquid, and its freezing point is 231.4 Kelvin. Freezing point is 231.4 Kelvin, and boiling point is 355.6 Kelvin. This you remember. Freezing point 231.4 Kelvin and boiling point 355.6 Kelvin. Laboratory grade nitric acid contains 68% of HNO3 by mass and has a specific gravity of 1.504. Specific gravity value is 1.504. In the gaseous state, HNO3 exists as a planar molecules. Planar, only in one plane. Planar molecules. With the structure, I am telling you that now HNO3 means 1 H, 3 oxygen, 1 nitrogen is there. Then here with N, 3 oxygen is attached. With 3 single bond. With N, 3 oxygen is attached with single bond. Means NO, NO, NO. And this angle between this ONO angle is 130 degree. All are not in this straight way. It is a angular. Here, angle is there. Then ONO, 2 oxygen you have used. Then N is in the middle. Angle is 130 degree. ONO. And one oxygen is third oxygen. Then bond length of this N and O, that is a single bond. All are single bond. Then now bond length between N and O, that is 140 picometer, 140.6 picometer, 140.6 picometer. And from this oxygen N and O, from this oxygen, one hydrogen is attached. One hydrogen is attached. Then O and H bond. Its length is, bond length is, that is 86 picometer. Its bond length is 86 picometer. And what is the angle between now HON? What is actually its angle? Then its angle is 102. Its angle is 102. And this ONO angle was 130. Then what is the bond length in that situation? With NO, in this I told you OH bond I told you that it is a 96 picometer, not 86, 96 picometer. And here NO, that bond length is 121 picometer. Okay, 121 picometer. Then this I have told you about the structure. It is a planar structure, HNO3. Okay, then here you this with N, 3 oxygen is attached. Then two oxygen is, one is upside, other is down, and its angle is 130 degree, and one oxygen is a straight way, that is a NO, and with that O hydrogen is attached, and angle is 102. Okay, and bond length between O and N, which is a straight, that is a 140.6 picometer, and other bond length, that is a ONO, then O and N bond is a 121 picometer, correct, and OH bond is 96 picometer. Now I will tell you further properties. This further properties means in aqueous solution, nitric acid behave as a strong acid. In aqueous solution, nitric acids behave as a strong acid, giving hydronium and nitrate ions. HNO3 plus H2O, it will give H3O, that is H3O plus, that is hydronium ion, plus NO3 minus, 1 minus, nitrate ion. This is very important reaction. HNO3 plus H2O, it will give H3O plus, means one oxygen, H2O will take one oxygen and it will convert to H3O plus, and H3O plus means hydrogen. This OH, actually OH, it will, H2O will take OH, then now it will become H3O plus, hydronium ion. Okay, HNO3 plus H2O, then this H2O will take OH, then it will become H3O 1 plus, that is called hydronium ion, and other thing it will product NO3 1 minus. Okay, this I have told you that it is giving two product, hydronium ion and nitrate ion, HNO3 minus. Now this other properties I am telling you. I told you HNO3 plus H2O, it is giving H3O. Then H2O, 2 hydrogen was there, one hydrogen they taken, one hydrogen. It became H3O plus, because H has 1 plus. That's why it became H3O plus. And remaining, what will remain? Then only NO3 will remain, because H plus gone. Then NO2 1 minus is remaining. That's why you will get H3O plus NO3 minus. But generally HNO3 that is losing as OH. Okay, it will lose as OH minus also. Okay, in some reaction you will find. Now other reaction I am telling you, concentrated nitric acid is a strong oxidizing agent and attacks most metals except noble metals. This is very important reaction. Concentrated nitric acid is a strong oxidizing agent, don't forget, and attacks most metals, many metals it will attack, except I am telling you noble metals. What are the noble metals? You should understand, I am talking about noble metals, not the noble gases. Okay, noble metals, its example is gold, platinum, etc. Okay, these are considered as a noble metals because it will not react. Okay, it will not react with air, water, even with acids also. Then it is called, that's why it is called noble metals. Then this after reacting with metals, with other metals, what product it will form, that I am telling you. The products of oxidation depend upon the concentration of acid, temperature, and the nature of material. Okay, undergoing oxidation. Which metal is undergoing oxidation, it depends on that metal also. Then three things, it depends upon three things: temperature, pressure, temperature, nature of the material, and main thing is concentration of the acid. Three conditions are there: concentration of acid, temperature, and the third is the nature of material undergoing oxidation. Then I will give some examples. Copper plus nitric acid. If copper is a metal, copper plus nitric acid means dilute nitric acid. If it is a dilute, then it will give three product, but main product I am telling you, NO gas, nitric oxide. Nitric oxide, okay, with dilute acid. And second, when it will react, same copper, if acid you will take concentrated, means concentrated nitric acid, then it will form another product, NO2. Now you can see, when dilute nitric acid you are using with copper, it will give you nitric oxide, NO. When you will use concentrated nitric acid with the same copper, then you will get NO2. NO2 means nitrogen dioxide. Correct? Now other I am telling you example, balanced equation I will tell later on. Now first this understand, dilute nitric acid effect we have seen, NO, and with concentrated you are getting NO2. Metal is the same. Now just see the condition with Zn, because now here again you will use dilute and concentrated acid, but now metal is different, Zn metal. Then with copper it has given NO and NO2, but now if you use the Zn, then what it will give? Then it will give now other oxides of nitrogen it will give. It will not give NO and NO2. With dilute nitric acid, with Zn I am talking about, it will give N2O, dinitrogen oxide, N2O. And if concentrated nitric acid you will use with Zn, then it will give NO2. Correct? But here one thing is that with concentrated, either it means HNO3, concentrated HNO3, either in case of copper and Zn, if acid is concentrated, then in both cases it is giving NO2. In both cases, if it is concentrated, acid is concentrated means nitric acid, then in both cases with copper and with Zn it is giving NO2. Okay, but one product only with Zn, with dilute nitric acid, it is giving N2O. But in the case of copper with dilute, it was giving NO. Then now you are getting in this 4 reaction I told you that in one product with nitric acid, dilute nitric acid, you are getting NO, and with second NO2, and with Zn Zn only it is differing N2O with dilute nitric acid, N2O, and concentrated again you are getting NO2 only. Okay. Then now I am telling you balanced equation. 3Cu plus 8HNO3. 3Cu plus 8HNO3. HNO3 is a dilute. It is giving cupric nitrate, CuNO3 whole 2. CuNO3 whole 2. 3 molecules it will give 3CuNO3 whole 2. 3 moles or 3 molecule you can tell. Plus 2NO plus 4H2O. This is the balanced equation. 3Cu plus 8HNO3 dilute, I am talking about dilute nitric acid. It gives 3CuNO3 whole 2 plus 2NO plus 4H2O. And with concentrated nitric acid, Cu plus 4HNO3. It gives CuNO3 whole 2. Same product, but only one molecule, plus 2NO2 plus 2H2O. Now with Zn you can see, with Zn 4Zn plus 10HNO3 dilute, 4Zn plus 10HNO3, it is giving 4ZnNO3 whole 2. Means you are getting, in all cases, you are getting nitrate. Okay. Cupric nitrate with copper and zinc nitrate with zinc. Okay. This is common. Nitrate is common in all 4. Okay. Then with zinc nitrate. Then 4Zn plus 10HNO3, you are getting 4ZnNO3 whole 2 plus 5H2O plus N2O. Again I am telling you 4Zn plus 10HNO3, you are getting 4ZnNO3 whole 2 plus 5H2O plus N2O. And last reaction, that is the Zn plus 4HNO3. Now it is concentrated. Okay, 10HNO3 that time was dilute. Now it is concentrated. Zn plus 4HNO3. Again you are getting ZnNO3 whole 2 plus 2H2O plus 2NO2. 2H2O plus 2NO2. Okay, this I have told you balanced equation, all 4 reaction I told you. Now other things I will tell you, other reactions. Some metals, as for example chromium, aluminum, etc., do not dissolve in concentrated nitric acid. This you remember. Question is asked, all questions, what I discuss reactions, all reactions are asked in examination. It is all. And so you should be very, very careful in writing the reaction or what are the products. That is very, very important. Condition, dilute or nitric. Okay, this you have to keep in mind. That's why I have given importance for these reaction. Now I am telling you, some metals like chromium, aluminum do not dissolve in concentrated nitric acid. Why? Why it does not dissolve in nitric acid? Because of formation of passive film of oxide on the surface of metal. Means, active, passive. Reverse of active is called passive, means it will not react. Then it will form one oxide, and that is called passive film. Passive, non-reactive, passive film of oxide on the surface. Due to that, it will not dissolve. Concentrated nitric acid also oxidizes non-metals and their compounds. Concentrated nitric acid oxidizes the non-metals also and their compounds. The example I am telling, iodine is oxidized to iodic acid. Example, iodine is oxidized to iodic acid, carbon to carbon dioxide, sulfur to H2SO4, and phosphorus to phosphoric acid. This you always remember, keep in mind, all are important reaction. You can't leave any reaction. All reaction you have to keep in mind. Okay, these are non-metals. Now already metals, for metals I told you. Now for non-metals I am telling you, concentrated nitric acid oxidizes non-metals and their compounds. Examples, iodine is oxidized to iodic acid, means iodine will lose the electron and it will become oxidized. Okay, then iodine is oxidized to iodic acid, first reaction. Second, carbon will oxidize to carbon dioxide. Here you should not forget iodine I2, that is oxidation state is 0 in solid state, and when it will oxidize as a iodic acid, then that time its oxidation state will change. Okay, as for example, HiO3, this is the acid, HiO3, then H is the plus, 1 plus, iO3 is 1 minus. Okay, H plus, this I told you, this thing, iodic acid. Then here if you will calculate the oxidation state, then suppose it is a iO7 1 minus, iO7 1 minus, then here this thing, you will find that now this thing, iodine oxidation state has changed. Okay, any iodate you calculate and you compare with iodine, that is the 0, and suppose it is HiO3, H is plus, then iO3 is 1 minus, then O3 means 6, then 6, you want to calculate I, then I plus 6, that is equal to minus 1, then I is equal to what? Minus 1 plus 6, that is the plus 5, means it lost 5 electron. Then like that way you can calculate these things, oxidation state. Then you will find it is oxidized. Same way carbon to carbon dioxide. Carbon C, that is oxidation state is 0 in carbon, 0, but in CO2 it is plus 4, because CO2, 2 oxygen is there, then minus 2 into 2 minus 4. Then obviously to neutralize this minus 4, carbon has to lose 4 electron, plus 4. Carbon will have plus 4, or you can calculate also. CO2, C converted CO2, then C plus O2 means 4, plus 4, that is equal to 0. Then C is equal to, O2 is equal to CO2, then minus 4, C plus minus 4, that is a minus 4, C minus 4, that is equal to 0, then C is equal to plus 4, then also it is oxidized. Then in general way you should understand that concentrated nitric acid also oxidizes non-metals and their compounds. Example, iodine to oxidized. Iodine is oxidized to iodic acid. Carbon to carbon dioxide. Sulfur to H2SO4 and phosphorus to phosphoric acid. Everywhere you will find that now their oxidation state changed. Oxidation state changed. Okay. Now reaction I am telling you that I2 plus 10HNO3. I2 plus 10HNO3. Then here you will get HiO3. HiO3 plus 10NO2 plus 4H2O. Then here if you want to calculate just only one, I will tell you, already discussed. I2 is equal to 0 oxidation state, and in HiO3 then H is plus, then IO3 will be minus. Then you want to calculate I, then I minus 4, that is equal to minus 1. Hence I will be minus 1 plus this minus 1 plus 4. 6 is HiO3. Then it is minus 6, I plus minus 6. Means I minus 6 is equal to minus 1. Then I is equal to minus 1 plus 6. That is equal to plus 5. Then here it is oxidized. That is the proof. I told you. Then iodine plus 10HNO3, you will get 2HiO3 plus 10NO2 plus 4H2O. And with carbon, C plus 4HNO3, you will get CO2 plus 2H2O plus 4NO2. In both reaction you are getting NO2. Don't forget. In iodine also, with iodine, with carbon, in both cases you are getting 4NO2. It will help you during writing the balanced equation. And carbon is converting to CO2, that you will not forget. And iodine is converting to iodic acid, that also you will not forget. Then confusion is in 4NO2, that you remember both will give NO2 only, and both reaction you will give water also. Okay. Then balance equation, C plus 4HNO3, you will get CO2 plus 2H2O plus 4NO2. Now with sulfur, now these two reactions you should be careful in balancing, and some hint I will give you, then you will quickly remember. Now S8 plus 48HNO3, sulfur exists in the S8 form, S8, okay, S8 allotropic form, S8 plus 48HNO3, 48 near about 50, don't forget, 48. Then here again you are getting NO2. With P4 also you will get NO2. Means everywhere you are getting NO2. In all four reactions you are getting NO2 and you are getting water. Okay, this is common in all four. Water you are getting and NO2 you are getting in all four reactions. Then here you are differing, their hint I am telling you. Then S8 plus 48, which is very high, it is not common, it is uncommon, hence you keep in mind. S8 plus 48 HNO3. Then in this case, because sulfur is there, S8, then you will get sulfuric acid. But what are the balancing time? You need some help, okay, some hint. Then I am telling you, because in balanced equation atom wise you will do, then same number of atoms should be there, both side, reactant and product side. Then S8 is there. Then 8 means, and it is forming H2SO4. Hence to neutralize this 8 sulfur, 8 H2SO4 it will form. 8 H2SO4. First hint in balancing. And 48 HNO3 is there. Then only one product is there of nitrogen. In product side, only one product is there for nitrogen, that is the NO2. Then for balancing, you will get 48N. 48 and nitrogen should be also, nitrogen atom should be 48. Hence it is very easy to balance. NO2 product is there, that you know. Then 48 HNO3 is there, means 48 N is here. Then with NO2 48 you have to write 48 NO2, same number. Then nitrogen is balanced. And then after that main things you have done, then quickly you will balance the oxygen, that is the 16H2O. Hydrogen and oxygen easily you can balance, because two major work for sulfur and nitrogen you have written. Then now H2O is there, main our product. Hence obviously easily you can tell, you can this balance the H2O, 16H2O, because now 8H2SO4 you got, means 16 hydrogen, total hydrogen was 48 hydrogen. Then 8H2SO4 means 8H2 means 16 hydrogen, and again 16H2O means 16 plus 2 32, 32 plus 16 48. Then 48 hydrogen we also balanced. Now come to the phosphorus, P4. It is also allotropic form, white phosphorus, P4 plus here 20HNO3, 20. It is also not common, it is uncommon. You remember, only in these two reactions this type of coefficients are coming. Hence don't forget. In exam time it will help you. P4 plus 20HNO3. Now already told you, here also NO2 you are getting, here also H2O you are getting. Then just like sulfur is giving sulfuric acid, here same way phosphorus P4 is giving phosphoric acid, H3PO4. Don't forget. Sulfur is giving sulfuric acid, then same way phosphorus is giving here phosphoric acid, H3PO4. Then now again is balancing is very easy. P4, 4P is there, and only one in P is only in phosphoric acid. Then obviously 4 you have to write. Product, in product only one, only in H3PO4 P is there, no other product is there containing P. Then 4 phosphorus is balanced, 4H3PO4. Now phosphorus is balanced, 20 nitrogen is there, 20 HNO3. Then obviously you should write only one nitrogen is there in product, then 20 there you have to write. 20 HNO3 means 20 NO2 product side. And after that very easily you can balance the water. Water is there, 4H2O. Correct? Then here 20 HNO3 was there, means total 20 hydrogen was there. 20 hydrogen. Then 4 here is H3PO4. Then 4 into 3, 12 hydrogen already is balanced. 12, then 8 hydrogen required. Then here H2O is there, then 4 you write. 4 H2O, then 4 into 2, 8. Then 12 and 8, 20. Then this I told you balanced equation, and these reactions are very very important, all with metals, with non-metals. I am telling you, each reaction you have to remember by understanding. Something product you have to remember. Other things I told you technique how to easily you can balance. Okay, and product you can remember. Then now I have discussed total 8 reactions. All reactions are very very important for all examination. Now again very important reaction I am telling you, that is the brown ring test for nitrate. This is very important test. If you will go in lab, that time we will do this test. We will do test of nitrate. Okay, test of ring test of nitrate. This is very important test in lab. Brown ring test. It is called brown ring test. Why it is called brown ring test? Because finally you will get a precipitate. Its color will be brown. Okay. Then what will you do in this test? How will you do? It is not difficult. Okay. But it is very important test. Familiar brown ring test. It is called brown ring test for nitrate. Then this test, nitrate test, depends on the ability of ferrous Ap2+. This you don't forget. Nitrates test for nitrates, this is brown test for nitrates, depends on the ability of ferrous ion to reduce nitrates to nitric oxide. This ferrous ion role is there, Fe2+ role is there. That Fe2+ will reduce Fe what it will do? Fe will reduce nitrates to nitric oxide. When here it is going to reduce, then just reverse of oxidize. Here that it will gain electron. Okay, nitrate will gain electron and it will convert to nitrate. Nitrates will convert to nitric oxide, NO. That is its a role of ferrous. Ferrous will convert or it will reduce nitrates to nitric oxide. Means nitrate will take the electron, its oxidation number will increase. Okay, or it tells simply you understand that now it will take the electron, number of electron will increase, very simple way. Okay, number of electron will increase. What was the beginning, and after this reduction their number of electron will increase. Simple way you remember. And oxidizing dying, who have oxidized, they will lose the electron. That means Fe2+, it will lose the electron, it will convert to Fe3+. But this nitrate will gain the electron and it will convert to nitric oxide. Then this is the role of Fe2+. Then nitric oxide formula is NO. It is a gas. This you remember. Then this NO gas, what it will do? Nitric oxide, what it will do? The nitric oxide reacts with Fe2+, because Fe2+ will take a little excess. Hence, this NO will react, or NO reacts with Fe2+ to form a brown colored complex. Very simple way. CO formed, CO0, NO formed nitric oxide. Then this NO plus Fe both will react. Fe excess Fe was there. That Fe will react with NO to form brown colored complex. How will you do the test? Now I am telling you. Final result I told you, but how will you do? I am telling you. The test is usually carried out by adding dilute ferrous sulfate solution. This is the main reagent. Okay. Dilute solution, ferrous sulfate solution must be dilute. By adding dilute, actually you will get this sample salt you will get. You don't know. you don't know what type of salt is there, iron is there or not, you don't know, but you want to confirm it. Then that salt you will take, salt solution. Suppose in that solution iron is there, you want to confirm it. This is actually confirmatory test of nitrate. Then here solution you will take, in that solution here this test is carried out by adding dilute ferrous sulfate solution to an aqueous solution containing nitrate ion. In salt, in examination you will get the salt, you don't know whether in this salt nitrate is there or not. Then you will make the solution of that salt, and in that salt you have to add this dilute ferrous sulfate solution. Then now ferrous sulfate solution you have added, then now it will start working. Ferrous sulfate solution means Ap plus is there, and now suppose in the solution nitrate is there, then obviously nitrogen will be there, then both will react. Then this, if you will add ferrous sulfate solution to an aqueous solution containing nitrate ion, then what will happen? And one more thing you have to add very carefully. Adding dilute sulfate solution to an aqueous solution containing nitrate ion, and then carefully adding concentrated sulfuric acid along the sides of test tube. This is very, very important. Addition of concentrated sulfuric acid you have to add. That is the third reagent. Means in a test tube you have taken the solution in which nitrate is there. Suppose nitrate is there, and ferrous sulfate solution already you added, dilute ferrous sulfate, and now just you have shaked. Now it is mixed. Now after that, after shaking, what will happen? You know, the reaction will take place between FeSO4, and if nitrate is there, then both will react and it will form NO gas. NO, nitric oxide, it will form. Okay, then now nitric oxide gas is brown, you know, NO gas is brown, but now you want to make in the form of gas will go outside. That's why gas should be there only. For that purpose you will add concentrated H2SO4 along the side of test tube. Slowly you have to add, not directly you can add. Very slowly you have to add along the sides of test tube. Okay, then as soon as H2SO4 will reach to the solution, you will find a ring. Its color will be brown. That's why name has been given brown ring. Okay, brown ring test of nitrate. Then a brown ring is you will find a brown ring at the interface between the solution and sulfuric acid, because you are added sulfuric acid slowly along the wall of the test tube, along the sides of the test tube, hence you will get a brown ring at the interface between solution and sulfuric acid layers. Then this ring test, this formation of ring indicates the presence of nitrate in the solution. Then its reaction is very, very important. All things are important. This is for all examination. I am telling you, main examination, advanced examination, IIT, medical, even for general examination also this question is asked. If chemistry subject is there in any examination, any general examination also, then this question will be asked. Then reaction you can write. Suppose in solution nitrate was there, then NO3 1 minus plus Fe2 plus, means that balanced equation if you want to write, you can write NO3 1 minus plus 3Fe 2 plus 4H plus, because you have added H2SO4 that produces H ion. Then 3 reagent you are considering: nitrate means NO3 1 minus, ferrous Fe2 plus H plus acid. Then it will produce NO. It will give 3 product: NO nitric oxide plus ferrous will convert it to ferric, ferrous Fe2 plus converted to ferric Fe3 plus water. These 3 are the product: NO plus Fe3 plus H2O. These are the products. Then balanced equation I am telling you: NO3 1 minus plus 3Fe2 plus 4H plus. It is giving 3 products: NO plus 3Fe3 plus 2H2O. Ferrous converted to ferric, don't forget. Now this NO gas, now its role will come, that Fe2 plus was there, ferrous, which you have taken in excess, and water is also there, because that was the solution. Then that ferrous exists in the form of FeH2O whole 6 2 plus. This is actually complex ion. Then this H2O actually it went to the d orbitals, vacant d orbitals. In that this 6 H2O went. Then actually this Fe2 plus exists in the form of complex ion, that is a ferrous hexahydrated. 6 is there. 6 means hexa. H2O is hydrated. Then ferrous hexahydrated, and you know that this H2O it went to the d orbitals, vacant d orbitals. Then H2O is a neutral ligand. H2O is a neutral ligand. Hence, if it will go to the vacant d orbital, it will not affect the oxidation state. Then that's why Fe was 2 plus, it will be again after making complex also 2 plus. Then FeH2O whole 6, this is the complex having 2 plus. Then this complex plus NO gas, which it formed in the first reaction, NO gas, it will form another complex. Then what is another complex? Then now for your easy understanding, I am telling you 6 water molecules was there. In vacant d orbital 6 H2O was there. Then from this 6 H2O, 1 H2O will come out. Then only 5 will be there. And in its place, NO will go. NO, nitric oxide, will go to the vacant d orbital. And now again it became 6 orbital is occupied, H2O came out, and Fe will have same oxidation state, means +2. Only 1 H2O came out, replaced with NO, nitric oxide. Hence you will get complex, new complex, in that NO is present, means FeH2O whole 5 NO, and outside 2 plus H2O. 1 H2O came out, that is the plus H2O. This is actually its color. This complex color is brown. Okay. Then this I have discussed about the ring test. Brown ring test I have discussed. Okay. Today I am stopping only here, and the next class I will continue with phosphorus. Okay, allotropic form of phosphorus I will discuss. Okay.